Concentric circles. Two concentric circles have circumferences 30 pi feet and 40 pi feet. Find the area of the ring-shaped region between them. Okay, so they're on top of each other, right? Concentric. Con, same, center, same center, concentric circles. So I'm going to draw these two circles over here, and I apologize for my lack of art skills. So I have a smaller and bigger circle, and of course they're going to be concentric. Here they are, they're concentric. And what we're trying to find, and notice that I'm drawing a general sketch here. I'm just drawing this general sketch. The area we're trying to find in here. And so this is helping me encode the problem. Right? I talk about metacognition and what I'm doing and being aware of it. You see that here it didn't even suggest to me use a sketch if needed, right? I went ahead and I started doing it so that I can see what's going on and start encoding the information and defining symbols as well, right? Because when I draw circles, we know the defining dimension of a circle is its radius. So these two things have a radius. I'll call it radius 1 and radius 2. Also, both of these circles will have an area 1 and an area 2. Why am I bringing up area? Well, they brought up area, really. Find the area of the ring-shaped region between them. Okay, so this is some geometry from a while ago. We're given circumferences and we're given area. Let's recall the circumference of a circle is 2 pi times r. The area of a circle A is pi r squared. Okay, so we see that there's a radius in both of these equations, these formulas that relate our ideas together, right? And I have two different ones. Notice that I use subscripts. I have a smaller one. I'm referring it to as 1, and the second one, the larger one, is 2. And I've used subscripts in order to do that. I've drawn them separately to begin with because they gave me information, right? They tell me that C1 equals 30 pi and C2 equals 40 pi. And so I'm encoding this information. I'm writing out what I know and what I don't know. I have a general form for C, and when I use it to solve for each individual circle, I can use the subscript 1 and 2 in order to delineate the two of them. So I have to relate these circumferences to the circles to get at the area between the two, the ring here. Okay, so it seems like we need to solve for the radius. And I'm going to say this loud so that we have a problem-solving strategy as we move forward, right? I can kind of see a few steps ahead. I can solve for radius. I'm given circumference. I can plug it in and I can solve for radius. Well, once I get the radius of the two, then I can find the area of the two because the area has the radius in it. So once I find the radius, I'd put it in here and I'd be able to determine what A1 and A2 are. But that's not the end of the problem because that's not what they're asking for, is two separate areas. What do I do with those two separate areas? Well, to find this region, all right, basically what you're doing is you're taking the area of the larger one, A2, and you're hollowing out, you're taking out of the center the area of the smaller one. So the total area, which I can just say, or let's call it a ring, right? That makes sense. They're calling it a ring. Find the area of the ring-shaped region. So I'll call it a ring, will equal A2 minus A1. Okay. So I'm like working in symbols. I'm going to notice that if I say a ring equals A2 minus A1, well, that will be, and we can make a note here, A1 is pi R1 squared and A2 is pi R2 squared. So when I take A2 minus A1, I'm going to get pi R2 squared minus pi R1 squared. I'm just going to factor pi out here just to make it a little bit easier. R1 squared. Okay, see how I factored that pi out? It's not necessary to do that step, but it is the elegance that we practice in math and physics. So let's see if I get R2 and R1. I can, if you wanted to, you could say, yes, I know. Yes. Yeah, I heard you. Yeah. I got a question. Can we factor this one more time? Yes, you can factor it one more time. Remember that the difference of squares here factors into this R1. Okay. You could do that if you wanted. It's arbitrary to me. Okay. So that's our bigger plan. We're going to find these radii. Once we get the radii, we can plug it in here, and we do this step, and we're going to have the area of the ring. Okay. So I'm going to say for C1, 30 pi, I know that has to equal 2 pi times R1. That has to be a true statement. Here's the general form of that formula, and I apply it in the specific situation with C1, and I have to do it with C2 as well. When I solve these two equations, and if you need to, you can pause for a moment. I'm going to go ahead. I divide by 2 pi on both of these equations, right? Divide by 2 pi here and 2 pi on this side of this equation. So 30 pi R1 equals 30 pi divided by 2 pi, which is 15. Nice. I'll do the same thing for R2. It's the same sort of equation, same structure, same knowns and unknowns, and so I get this to be 20. And of course we're in feet, so I'm just going to note feet here. These are nice intermediate answers that I might check for example, on a quiz or an exam. Did you get any immediate answers that I can give you credit for? Okay. So now that I have 15 and 20, I can use that down here, right? R2 equals 20 and R1 equals 15. So I can plug those values in. I'll get pi times 20 squared minus 15 squared. Plug this into the calculator. 20 squared minus 15 squared is 175 pi. And just to have a decimal, a ring equals, I'm going to multiply that times pi. Let's see, 549.78 feet squared, right? We have 20 feet squared and 15 feet squared, which results in feet squared. So I'm going to round this. Notice that I have 1 sig fig. I'm going to round this to 2, 550 feet squared, and let that be the end of the answer. Okay. Does that make sense? Yeah, I have 20 and 15 feet. That's somewhere in the hundreds of feet. I'm okay with an area being that big with that big of circles. All right. What else can we look at here? And like I noticed, the units get squared in here, so I get feet squared, which is what I expect for the dimensions of an area is square length squared. Okay. I didn't use this version of it. It was just as easy to do this. So